Hello everyone, this is Alex Designman. In this video I would like to review a portfolio for a project that one of the guys in my courses sent me. So this is more like a presentation showing everything they did in this project in a university. It's the Transilvania University, so it's the racing team of Transilvania University. They did this vehicle, and the student's name is Florin. So this is from his LinkedIn, if you want to get in touch with him to ask him something. So he currently works at Bugatti Rimac in Croatia. So he still works with supercars. But this project was very interesting, so that's why I wanted to make this review. Also because it kind of reminds me from my years of working in Formula 1. So 40 years in Ferrari Formula 1 in Italy, and also in Red Bull Racing in the United Kingdom. So this is the first page here with a picture and everything, so everything is cool here. Then we have this page saying team presentation, and on the next page there are pictures with the entire team. So I think that here under each picture there is enough space to add everyone's name, and maybe you can write who is the leader or something like that. Next, introduction stuff, inspirational words. So I like this: without data you're just another person with an opinion. I strongly agree with this and I apply it in my projects. Okay, let's go forward. Here we have some abbreviations for everything that it's being used in the presentation. Documentation structure. So this shows what's the structure of the documentation and what are those documents for. So this is pretty cool for a presentation. People that haven't worked in a development of a project like this one, they might not understand everything, so it's good that there is here kind of an explanation. So it's a cover page, you have the BOM, have ICE schematics and layout of temperatures, form board, low voltage for ICE, so this is the form board harness for the ICE. Project content, we'll see what this is. Components location, so this is very good. Electric harness schematic for the ICE and fire plate area, so those form board and electronic schematics, you have them here. And the manufacturing board for the internal combustion engine. Then we have low voltage documentation, cover page, electric harness schematic, manufacturing board, components and layouts, form board for electric harness front. And then we have safety, so this is important, safety components, location on the car. So this is safety inside the vehicle. Electronic schematic including positions on BS22, BOM, safety components, cable length, so we are going to see what kind of safety components they have. Electrical harness design and manufacturing. Okay, electrical harness list of topics of improvements. So this is good to show, like it's showing how do you start this, basically what do you do from the first time, the brainstorming. And here is, you're going to have sensors obviously, so for the sensors in the harness you're going to need the supply, ground, shielded cable, sensor types and analog voltage, power grounding, circuits, common paths. So it's good to think about common paths for grounding so you can reduce on wirings and weight. Star point, earthing, body grounds, so also those are important. Power supply, power consumers, sizing the wires, sizing the fuses. So first we start with the power, electric consumers, fuel injectors, ignition coils, switches, solenoids, fuel pump, ventilators. So there is a lot of stuff to think about. Electrical harness structure of building new harness. Specifications and circuit design. So first you start to design the circuit, and here all sensors have been identified and all data sheets have been centralized in a common location. So after you identify all the sensors in a project like this one, you need to centralize all the data sheets for each sensor in a common location, somewhere on the hard drive, in a folder, so that everyone will refer to the same documentation. So this is how you avoid errors, and this reminds me a lot of Formula 1, because they don't use fancy softwares and stuff. There is no time for that, and fancy softwares are slow, and many times they need to access the data while they're at the races around the world. And if the server it's in Italy, in Maranello, in Ferrari, and they are in Australia, they need to do that fast. So for data we use Windows, we use folders in Windows. There is no software database or something fancy. And for sensors we use Excel. It's very simple, and they do that the same thing here, so it kind of reminded me of that. Layout and routing design, wire preparation and splicing, wire assembly, building, branching and sheeting. Okay, booting preparation, so we're going to see about those. Step 1, specifications and circuit design. All sensors have been identified and all datasheets have been centralized in a common location. So it's very simple. You have one Excel file where you have all the sensors. So we use in Formula 1 we used to have like one of those tabs, and all the sensors for the whole vehicle for the whole season were in that file. And sometimes there was like a free row and it says engine sensor, and you see engine sensor, and then there was gearbox sensor and gearbox sensor, and then there were front chassis sensors and drive wheel sensors and so on. So there were just a few sections, and then there were sensors for all the sensors for each of those sections. So you have like the type of the sensor, the name, it was also the voltage that the sensor was using, how many pins or wires does the sensor has, and all type of information, like it's an analog, it's a digital sensor, and so on. So from there you take your sensor. We also had a part number, an internal part number of the component, the part number from the supplier, the name of the supplier, or everything. And then there was a folder where all the data sheets, they were in there, and you would study forward the sensor from the data sheet. So again, no fancy softwares, because in domains like this you do not have time for that. Step 2, layout and routing design. So in here probably they didn't do 3D design, so they did the harness directly on the chassis. So I remember Red Bull Racing, they didn't have the 3D design for wires until I think 2019, and they just had an Excel file with the pinouts. That's it. And they would do the harness hands-on. The technical team will do the harness hands-on on the vehicle. So this is possible, but now they do have a 3D design. So here you have the ICE, the chassis and everything. So let's go forward. And this is the board for the harness design. So it's the same thing that I'm showing in my courses, how the harness design is done. So you need to put supports everywhere to make the routing, labels, and so on. So this is like a diagram for sensors. This is for the so this is for the board. You can see it's exactly what's on the board. LabVIEW, cable calculator application. Okay. Step 3, wire preparation and splicing. Step 4, wire assembly, bundling, branching and sheeting. So this is in here they start to do the harness. So I see they use motorsport material. So this, I think this is Kapton tape and thermo-retractable stuff around here, and motorsport connectors. I can see those. So they had good funding. This is expensive stuff, but I think this is those are used materials from a helicopter. So you'll see that forward. Booting preparation and labeling and color standardization. So this is how you need to add the labels everywhere with the number of the harness or branches if it's needed. So in Formula 1 there was only one label on the harness, and with that, the code on that label, you can access on the computer the drawing, so you can see everything, all the other stuff. But there are also labels indicating if you have a connector on a branch, it says C1 or C2, C3 or other stuff. The cable at the end have different colors to be easy for identification. So signal, 12 volts, 5 volts, GND, ECU GND. Yeah, so in the industries they do, many times they print this on the wires, so on the small wires that are inside. They have printers that they can print with laser, the name of the signal and everything. I know that in automotive mass production they do that, and in Formula 1 they put labels inside this boot here. Classification wires and crimping types, so you also need to standardize what type of crimpings you are going to use. Classification for crimping tools on AWG, and type of connector, classification from shrinking tube, using shielded cable for better signal isolation. So you need to make some standards when you do those harnesses. Okay, so after you add all the wires, you start to add the connectors and to terminate the branches with the final dimensions. And you also need to do testing to see if everything works, of course. So there is here a connector which is for engines. So this looks like a military connector. Environmental impact. So study was done to identify the places where the critical area are what can be recuperated from the helicopter, electric harness, tag holder with experts from local helicopter factory. So they reused cables from helicopters. So that's very good. Helicopters, they use the same type of materials that they also use in racing. So it's the same standard. So I went back just a little because I wanted to add a few things here for the review, and I'm going to go faster forward because Florian made a video explaining more of what's going on here. So I'm going to show you the link. So the link of the video will be attached to this video in the description if you want to see more technical details. And what I would like to see here is LabVIEW cable calculator application. So I would like to see like an explanation of what this is, what's going on here, and how to use LabVIEW for this and why. So this is important because other companies might use other softwares. So it's good to understand how, like a short explanation, so nothing too complicated. Then, okay, so going forward, this is pretty straightforward. So it would be good to know here how do you calculate where you should use shields for cables or not. So what is going to, like, how do you take the shield off, because it's good to add all the shields. So many times in Formula 1 they used to add shields and then they take them off and see if there is any problem in the circuit. So they do that a lot because it's easier than trying to think about it too much. They just do not have time in there, so it's better if they just do it and see what happens. So I'd be interested to see how here was this done. Okay, so I understand this is the engine harness connector. Okay, so this is straightforward. And now documentation BS22. And here it would be good to explain what this is, like price explanation and bomb. So what this is, I see some big prices around here, so it would be interesting to understand what those are. Forward weight reduction, so the same here. I would like to know what those are. So is this the actual weight or it's a comparison? So this is the BS 2021, so from 2020-2021, and BS from 2022. So you can see, so it would be good here to make this comparison a little more clear and straightforward to show exactly what was reduced from the previous model to the new model. So I think it's simple like that. And improvement analysis, problem, electrical harness, no labels, no bench testing, equipment not available, finances. Okay, department office is split with other department. Okay, so problems and solutions. So I like this: organizational, work time, task, workflow management, system, fixed program, and flexible program. Okay, so this is the schedule for doing this project. So this is interesting because in racing you're going to need to have a schedule. You cannot just work freely because the project needs to be done at a certain date. And I would put the status meeting on Monday. A lot of companies do that, so they start the week with where we are and what do we need to do, and usually they do that first thing in the morning. So everywhere I've seen this kind of meeting, in Monday morning you start the week with a meeting where we all see where we at and what we need to achieve. Description: low current circuit, high current components, high temperature. Okay, so this is the high temperature area where the engine, high current circuit, so because there are the fans here for the motor, low current circuit. Okay, so it's showing how the harnesses are located, the ECU, the power module. Okay, yeah, so this is a simple racing vehicle, but if you want it to work properly you still need to do those kind of projects if you want this to be competitive. So here is a better view. So the ECU is here, so I assume the ECU means engine control unit, because in even in racing and in In automotive design in general, ECU means electronic control unit, and it refers to every control unit in a vehicle. But I know they also use ECU for engine control unit, and sometimes we use ECM for that, engine control module, just so that it's not confused with ECU. A relay box, so it's in here inside the vehicle. LCD display, okay. BSPD, I don't remember what this is, okay. Time plan for BS 2022, so this is the time plan. Oh, so they have vibration simulation, structural, developing case module. So this is so you know all the components, what you need to do first, and what you need to have ready for the going forward. So I guess this is the stop from the back of the vehicle. So it would be nice here if it would be, so all of those, they will have text saying what they are. So this is harness, this is a box, it seems like a box, and I don't remember what this is. So this seems like the stop, like the rain light that they have in Formula 1. Okay, and the LCD display. Okay, the electric harness, so this is the diagram for the electric harness. It says here more info in the appendix, so we'll see that. Relay box, so this is the relay box. So this is the development process of the relay box, I think, so I don't understand exactly what this is. The LCD display, so this is the electronic diagram for the LCD display. So I would be curious here how detailed was the development of this. Like you guys did this diagram, or you just brought LCD display from somewhere. So you did this from scratch and you order it with a company. That would be interesting to know. And the BSPD, I don't remember what BSPD is, so I guess that's why we have the abbreviations at the beginning. So even if you have abbreviations, I will still write some stuff, because you have to go back forward if you don't remember something. And this is the CAD view of the circuit board. Yeah, so it would be good if those are shown here, like to add more explanations about what's going on here. Stoplight, so yeah, just a simple stoplight with LEDs. And those are thermal analysis. And in here would be good to know how the thermal analysis was performed. So was this done on the spot, like on a dyno, or was this done on the track with the vehicle rolling? So I see some hot stuff here, and some also the tires get hot. So measurements, spot 1, 2, 3. So I guess those are the spots. This 1, 2, 3, 42 degrees, 39, 40 degrees. So this is warm. So this is warm, but it's not very hot. So it's kind of a good temperature around here. And in here, spot 1, I guess is this one, 61 degrees. So this starts to be hot. Okay. Standalone ECU, this engine control unit. Okay. And those are more details about the engine control unit. Okay. Bench testing, this is the building board, if I remember well. So it would be good to know what kind of bench testing was done. So you see how this vehicle looks. It looks pretty cool. Testing session on the racing track. Pressure of tires, tire temperature, overlap. Okay, so this is temperature. And here we have acceleration overview with timings on the track. So this is relative to the track that they have there. Bugs from testing sessions, spikes fuel pressure. So those are things that need to be investigated. Spikes fuel pressure, fuel lighter going. So I don't understand what is cause. So I think this is cause. Solution replacement of the filter. Okay, probably this should be fuel filter. Go light. Okay. Spikes front wheel sensors, distance of 1 mm, so adjust 0.3. Yeah, it would be cool to know what this means, just for engineering fun stuff. Spikes on VSS straight line. VSS was the cause, fixed VSS, so vehicle speed sensor. Yeah, it would be cool to know what was the problem with the VSS. Spikes on the back wheel sensor, distance 0.8 mm, adjust 0.3. So I guess this is spikes on a diagram, but I don't know what's the distance and adjustment. What are you doing there? Temp sensor calibration, scaling calibration. Okay. shifter block-up, bad contact steering wheel. So yeah, when you do those kind of vehicles, those kind of engines, they have high frequency vibration and they can ruin a lot of stuff, including contacts and other stuff. So I remember when working in Formula 1, they had a problem with the injector coil, that because of the high frequency vibration of the engine, which works at 20,000 rotations per minute, the resin in the coil was cracking, destroying the coil. So they didn't know what to do, and they had to mount the coils of the injectors on anti-vibration mounting devices. So they had to modify all the injectors and they cost a lot to put them like that. But high vibrations in engines like this, they can crack everything and destroy contacts. Electrical harness conspectus. So this is like a study that was done for electrical contacts in automotive applications, done by Aptiv Technical Center, so I know this company. But the automotive applications is this mass production automotive applications, because it doesn't really compare with racing. In racing there are those high frequency vibrations that I was talking about coming from the engine, so they can have more problems. You do not have this on mass production on road vehicles. Assembly of the wire harnessing. Okay, so those are connectors used in road vehicles, so those are not racing connectors, even if they have seals. Salt spray environmental testing for contact points, so the salt spray test. So yeah, they do that in automotive connectors to see if contacts and connectors they resist to corrosion, because the salt spray represents I don't know how many months or years of normal water. But again, this is for mass production automotive. I don't think this applies in racing, because in racing a racing vehicle needs to work for 1 season, for 1 year, even less than that. So I remember a Formula 1 engine, it was supposed to go only 400 kilometers, so they didn't care if they would change it. Electric harness and heating during running time, isolation importance and air gap. Okay, so I don't really know what those are. They look nice, so it would be nice to have some explanations around here, like have this text smaller and just write here what's going on here, what are you trying to achieve. Importance of fuses in the electric harness. Yeah, so this seems like a basic thing to me, importance of fuses in the electric harness. I don't think we can say that are not important fuses, so they are always important. Everything should have fuses. Risks of wire harness in real life, criteria for assessment, system levels and micro levels. So I don't understand what those are and what was the purpose of this page. But maybe something that they are asking to have on the university. Maybe there is a requirement somewhere around there. And this one on electrical terminal can be defined as a component of a couple. Okay, so those are information coming from somewhere else. I can see their screenshots, so I don't really understand what those are. Electrical terminals. So those are pins and socket, I think, in connectors. Okay, pin and socket. Around here, crimping, critical area, so showing crimping. Okay, so this is showing the correct way of crimping, so this is okay. So this says how the bench testing is done for continuity using multimeter, using the Excel file, and testing on the car for continuity using the Excel of connections and labels. So you test one, so first you test it on the bench for continuity. Then you test it on the car for continuity, testing signals on the car using oscilloscope. So you see if the signals are okay. Okay. Common topics. Analyzing data from the racing track. Oh, I like this stuff. I used to see this stuff in Formula 1. So this is oil pressure. So oil pressure was very high, and then they fixed it and it got lower. Yeah, so it'd be cool to know what was the problem here. Okay. Analyzing data from the racing track, before, after. Yeah, so this is showing like an example, but again, it's cool to know for the fun of engineering what was going on here, what this is, where is this diagram coming from, what was the problem here and how it was fixed. Thermal analysis. cooling capacity of the radiators, uniformly heat displacement, okay. Exhaust pipe and engine analysis, okay. So you're watching how heat is displaced. You need to do that in a racing car, and with thermal cameras is the best way to do it, okay. So this is the last page on the presentation, so I think it would be nice if you have a last page saying thank you for watching this, for taking the time, thank you for all the team, something like that, something nice. So I think that would be pretty good. This is a long presentation, it has a lot of pages. So what I think it can be done better here is to have more direct explanations about what was the work and what were the problems. Like just examples, they're not going to be the same everywhere, but it's like a story. So this should be like a story. And also remove some of the pages that are not that relevant, like importance of fuses in electrical harness. So this is not that relevant. It's we all know how important they are. And there were others around here, like for crimping you can have only one page. Crimping can be made pretty simple, and it can be more of this, like track data and thermal analysis and stuff. But this was a complex project, and it was a lot of work done here. And also to put, when you have a lot of information, I think it's good to have an idea on what you want to transmit with that presentation. You want to transmit a story, you want to, for who you make a presentation. Was this done for the company, for the sponsors, or for the general public, something like that. So if you do this for the general public, for example, it's good to do it like a story, like make it fun, show a lot of information stuff, because people that are in this domain, they like to see that stuff. But overall, this was a great presentation for who works in racing and or wants to work in racing. I think you should watch this presentation again. So I think you should study all of those, because you don't find, I don't think you find anywhere this kind of information around on the internet. This is something very, there are a lot of things that I've seen here that are actually done in Formula 1 and in racing in general. So this is what they do. They need to test that vehicle a lot, so they build and test. So this is not mass production automotive, this has nothing to do with road cars. It's a big difference between them. So with this being said, I hope you enjoyed this video and see you in the next one.